Hi, good day, all of you. Hope my voice is audible to you. Yeah, welcome to Logic Design Lab software part. I'm Salman Arafat Muhammad. So I'll be taking you the Logic Design Lab for software part. Hardware part will be taken by other engineer. And this is the lab manual which I have prepared for you, in which there are total three experiments. The title of the first experiment is Logic Gates using Multimedia Logic Simulator. Okay. Similarly, you have the remaining two experiments, and the lab reports have attached at the end of this manual so that you can take printout, and whenever we completed any of the experiments, you can write those lab reports in these printouts and submit to me manually. This is the first experiment about logic gates using multimedia logic simulator. Our objective of this experiment is to introduce the multimedia logic software, which is MMLogic. This software you can get it through online with the help of Google. Just go to this Google and type here multimedia logic software download and click on the first link, and you will get the downloadable link, and it is a very small software. Click on download, it will download automatically. Okay, so the other objective is to study the basic logic gates and or NOR XOR gates using this multimedia logic software. For this you need to have a computer with this MMLogic software. It's very small software, and you just click it and click OK. It gets installed. It's a very small and easy to install software. Okay. Now, with the help of this multimedia logic software, you can simulate a circuit which has switches, okay, and LEDs and the control components, which I will be showing you shortly. This is an example that you have a battery and you have a light, and the circuit is connected, and the circuit is open circuit. When we make it short, then a light glows. This you can do with the help of the simulator with switch as an input, and this is an LED. Just you connect it, and you'll get the light. I'll be showing you this in the experiment. And the information about this multimedia logic simulator is that it's available in the lab manual. Please read it. Okay. It's a logic simulator. It's a simulator which has 6 states as given here. Okay. And it has 4 modes of operation: ready mode, drawing mode, running mode, and the pass mode. And you can move into these modes with the help of these buttons. The setup is very easy, as I have shown you. So we will be just getting the we will be designing the circuit for this simple basic gates using multimedia logic simulator. Already this information is there in the lab manual. Okay, you have to read it for submitting the lab reports. Okay, so let us begin with the experiment one. Before I begin, let me give you let's go to the page 19, from where you have all the lab reports. Okay, all lab reports for software part are attached here. Okay, so here you will be, this is the first page of your lab report, and I'll be showing you how to write this lab report in this experiment today. Okay. Also, if you need to get more information about the components which are there in the multimedia logic simulator, this is a textbook. It will be available to you through the instructor with whom you are enrolled in the Blackboard. Okay. So it has some information about all the components which are there in the multimedia logic simulator. And also at the end, I have given one small tutorial that how to use this software for designing the circuit. Okay. So this is using multimedia logic. You can just read it step by step and do it if you have missed this lecture, or just watch this lecture. You will get easily how to use the simulator. So I have the simulator already installed with me. So I'll just directly go to the software. Just I double click on the software, then click on the close button. Okay, make it big. And sometimes what happens is you will not find this and this, because when the first time you install, you get a screen like this. So don't get panic. Let me check, is it recording? Yeah. So don't get panic with this. Just you click on this, you will get the screen, and you can just make it big and zoom out. And for this, this is your drawing area, and you can use this drawing area. You can draw this. You can draw the circuit here with the help of your toolbox. And toolbox is also not visible. You can click on this toggle palette. Okay, you'll get the toggle palette here. Okay, now all these components are, you see, just take it down, you will see the name of these components. Okay, all these are the name of the components which you will be seeing here. So now let us start with our first experiment. Okay, this is your uh, first experiment. Yeah, so how do you write the lab report? Just I'll give you a brief information about. You have to write your name here. Yeah. Write your name, your section, lab code, your lab name, software part. Okay, logic design lab software part, and these three, your course code, everything, and write the experiment date and when you are submitting it. And deadline is generally 1 week, and this experiment number one, and write down your serial number and your Rakham Jami. After evaluating, you will get the marks here. This will be filled by me. So write the title of the experiments and the apparatus which you are using here. Now make sure that the apparatus which we will be using in today's experiment is, you have to write here. And just for example, I'm writing, you are using switch, you are using LED, and using AND gate, OR gate, XOR gate, okay, and inverter is also called as NOT. Okay, so just make this list big according to this, and you'll be using XOR gate, uh, NAND gate, everything. So write down, and here at the same time you just write down, instead of model number, write the type here. So switch is an input device, and LED is an output device, and is a control device. Similarly, XOR is a control device. All this information, where do you get? You can get this from the lab manual and the textbook what I have shown you just now. Okay, and you need to write about this switch and this LED, about this component, from the 2-3 lines in the lab manual at the back of this page. So for example, I just show you for example. You see, you want to know about switch. Just I write the switch, uh, like switch device. Okay, switch device. Now, the switch device is a two-stage input device. It can be used as both an interactive input device as an alternative to using ground. So here it is mentioned that it's an input device. Okay. Similarly, you have a LED also. So LED is a simple device that reports to you visibly. Okay, what its input signal is doing. That's of course off, one, and so whatever it's an output device. Okay, it's a simple and output device, and it what input it gets simply displays as an output with glowing. Okay, so like this information you can get from here. Okay, so now here it is showing that the English you can read here, and I will be showing you in actions what is meant here, like double click on the multimedia logic icon to start the program which I have shown you here. Okay, so now it is saying that to get one AND gate. Okay, and click on this AND gate, and how to add the components, which is given here in the next slide. Yeah, so this is the toolbox you have in the window, right? So click on this undo actions, do actions, all these things I'll be showing you, and it is giving you instructions for simulating this kind of circuit, right? Simple AND gate. So for that, what you have to do is, as shown in the figure, it has two input devices, switch 1 and switch 2, and one control AND gate and one LED, and the name of this input signals are A and B, and output is F. How do you get this? You see, this is the switch. Click on the switch, and click don't leave the mouse, and select appropriate place, and then leave the mouse. Okay, so it will be connected. Suppose by default you have just added some more components, so you can delete it by just clicking this arrow. Okay, then click on this, right click, delete, or select this, right click, and delete. Okay, this is the way you can delete or undo the changes. Similarly, now you can have an AND gate. Click on this and click on this white area and select appropriate place, and then leave the mouse. And for AND gate also, you can uh, click and drag and drop at appropriate place and leave the mouse. And this is the text for giving names to the input and outputs. And these are the wires. Don't use this nodes. We'll be using wire throughout all of our experiments. Now, how do you connect? You see this black dot to this black dot. Take this plus sign intersection point and click, and don't leave the mouse button, and take that intersection point to the of the other node and leave it. So in this way it will connect to the gates. Okay, and click on this arrow and double click this and give the name as an A here, and here give the name as B, and here give the name as F. Okay, so this is how we have got the circuit. Okay, now after this circuit is given and we have connected, now this is not running. You can click this on button and you can stop this with the help of this red button. This is what it is saying, that you see this is not running. Now I will power on this just by clicking on. So my circuit is running, and now you can see that when two inputs 0 0 0 1 and 1 0 and 1 1, then it is on. When it is turned on, the LED glows. It means it is F is 1. If it is black, it means F is 0. So this is running. Now I can stop it by just clicking on this red button, stop. These are first circuit. Okay, and from this circuit you have got to record the output like this. Okay, as just now we have seen that when I give offer like uh, in the circuit, I just run again. When 0 0, output is 0. Okay, it means it is off. When B is 1, still output is 0. It is off. And I make 1 0, output is 0. This is off. And 1 1, I will get output as 1, which is on. Okay, so I stop the simulation. This I got. After getting this, you have to do two things. Explain this truth table. Now you see, you observe this values. Okay, now when input, any one of the input is 0, output is 0, otherwise the output is 1. So explain this. So I write here that if any input is 0, then output is 0, otherwise the output is 1. Now you have to write here the Boolean expression also. Okay, Boolean expression. Now, how do you write the Boolean expression? It's very simple. Just see, for writing Boolean expression, sum of products, you make f is equal to 1. So you see in this, where is the output is 1? This is the output 1. So I will take these input values. Suppose the value of a here is 0, I will take a bar. If the value of a is 1, I will take a. So we will use this notation. Okay. So here I have only at one row, I get the output as 1, which is a dot b. Correct. So I write f is equal to a dot b. This is my Boolean expression, right? And here it is saying that you can also observe that in your AND gate, suppose you have taken this AND gate, it is having two inputs. Now suppose if I want to change it to three inputs, right click on this, go to properties, make three inputs. You will get three inputs. If you want four outputs, go to this and just make it four outputs, you get it. Now this is AND gate, right? I want to have only two inputs, I just select two inputs. I want to make this NOT gate, NAND gate. Okay, so I just right click on this, go to properties, click on this invert output and click OK. It will give me NAND. Okay, so for all the gates you have some properties and you can change it and get accordingly. So now in the next part, here he has asked you to convert NAND gate with three inputs. Okay, and like how we have simulated this a b, you should have these three inputs a b and c, connect f. Okay, and record the outputs for this. Okay, and then write the Boolean expression and also explain the table here. So this I'm leaving to you, so do it for three inputs. Now let's go for the step number 16. Now here in step number 16, this is very important. Here you are supposed to, I'll just take down this, let me increase the size here. Okay. Just try this to make writing area. Yeah. Now I have this. So let us see that now he is asking to repeat this experiment for all this. So I'll show you some of them and you can try for the remaining. So first let me show you the NOT gate. Now NOT gate here, and now for this you go for the new project. Okay, now we go for the new project, zoom in, and let's take two inputs, because you see here it's given inputs are to a and b. Okay, these input names and these are the output names. Okay, so I take two switches a and b as an input, and I take invert. See, invert is nothing but your NOT gate, and output is what? Okay, output is f. So here now it is taking from only a. You see here the NOT is having only one input, considering input a only. So only we just take an example for a only. So here you have only a. We are not using from b. Okay, and then this is the output called not a. Not a. Not of a. So let's give connection. How do you give connection? I have explained you right already. Now you see when I run this, when input is 0, output is 1. When input is 1, output is 0. So I just write down here. You see that yeah, when input is 0, output is 1. When input is 1, output is 0. This is NOT gate. Okay. So it means how do you now how do you write explanation about this NOT gate? So here you have to write explanation as, okay, if it is giving the opposite value of the input. Okay, it is giving the opposite value of the input. So write down the explanation and write the Boolean explanation, Boolean expression. Okay, what is Boolean equation? Boolean equation is f is equal to, you see, if it is a, it is if A is 0, it is 1. If A is 1, it is 0. So F is equal to A bar. This is the Boolean expression. Okay. So similarly, you are having for NAND gate. So I'll just go for the next part. Okay, stop this and go to the new project. Just make zoom in. So here I will be having two inputs, A and B, and I will be having AND gate. And so it is giving as NAND gate. So this is AND. I will right click, go to properties, and I will just invert this output so that I get the NAND gate, and then connect the inputs as shown, as because it's a two input gate, and let's give the name as this A and B, and this is NAND. Okay, so I just give this as an A, this is B, and this is NAND gate. Okay. So I run this. So see, both inputs are 0, output is 1, and both inputs are the 0 0 0 1, output is 1, then 1 0. I make it as 1 0, output is still 1, and both are 1 1, then output is 0. So what explanation you give here? Okay, the explanation this is that if any of the input is 0, output is 0. If all inputs are 1, then output is 0. Okay, this is working as X, as opposite of AND gate. That's why it's called NAND gate, right? So how do you write the Boolean expression? You write F is equal to 1, right? So where is 1 here? 1 is here in this row. So A bar, B bar. So I write A bar, B bar plus, this is also 1, so A bar B plus, this is A B bar. A B bar. Now, if you want to do simplification, you can simplify the Boolean expression. It is up to you. Okay. So in examination, if it is asked simplified, you have to write simplified. If it is asked only write the Boolean expression, write only the Boolean expression. Now, similarly, you can go for OR, XOR, OR, NOR, XOR, and XNOR. Just for example, now you have to stop it. Now this is your OR, this is your XOR, right? And for example, you have OR, you have XOR, right? Now if you just make an invert properties, you will get XNOR. Okay. Similarly, OR, if you make it not, you will get XOR. NOR, sorry. So you'll get NOR. This is XOR, this is OR. If you make invert output for XOR, you will get XNOR, and for OR, if you invert the output, you will get NOR. Okay. So similarly, you can just try for all of these combinations. Okay. So now I'll be just solving one thing here, XOR, for example. Okay, let's take this. Okay, so I will simulate the circuit for XOR. So I'll just go for the new project, and I will take XOR, and I will take two switches and one LED, and with the help of wires, we'll connect them. Okay, and let's give the name of this input. There are two inputs, so the name of this first output is A, and this is B, and this is XOR. Okay, so now I just run this. Okay, when two inputs are 0, output is 0. So I write this is 0, then 0 1, output is 1, then I will get 1 0, output is 1, and both are 1, output is 0. Okay, so now explanation, what do you have to write the explanation here? Explanation is, you see here, just observe here. Okay, when the inputs are same, you are getting output as 0, correct? If the inputs are different, then you are getting output as 1. So this is the explanation. Okay. So write the explanation in your own words, and then write the Boolean expression. F is equal to 1. Okay. You see where is F is 1? F is 1 for these two rows, row 1 and row 2. So you just see in row 1 A bar B, and here A B bar, right? So F is equal to A bar B plus A B bar. This is a Boolean expression. Now, also that this very famous operation XOR, this is also known as A XOR B. Okay? So F is equal to A XOR B. A XOR B is written like this. Okay, like AND is done with the help of, not is with bar. Okay, and is with the dot. Okay, NAND is with the negation, and OR is with the plus symbol, right? And NOR will be the negation of it. XOR is this symbol, and XNOR will be using this symbol for it. Okay, so complete this table and write the explanation of each of the output, that how you got the output, the behavior you have to explain in English, and also write the Boolean expression. After doing this, next part and the last part is this. See, so far we were seeing the table, we are seeing the circuit, implementing it, constructing a truth table, and from the truth table we are deriving this Boolean expression. Okay, now the situation is different. It is reverse now. Now Boolean expression is given. From this Boolean expression, you have to draw the table, and you draw the circuit and get the table. Okay, this is reverse. I repeat, in the previous uh, projects, in the previous parts, we are doing that. Only circuit was given. We are just drawing we are simulating the circuit. With the help of the circuit, we are filling the table, and from the table, we are deriving the Boolean expression. Now, Boolean expression is given. So, from the Boolean expression, we'll draw the circuit, and from the circuit, we draw the table. Okay. So, from it is clear from the Boolean expression that F is equal to A B bar XOR, correct? A B bar, this is XOR C. Now we have seen all these operations, dot also, and not also, and XOR. All we have seen in the previous parts. So now there are how many inputs? A, B, and C. There are three inputs, correct? So let me draw the table. Okay, we are having inputs as three. One is called A, another is B, and another is C, and there is one output called F, correct? One output called F. So let's take this line, right? So if there are three inputs, how many possible combinations, output combination, input combination you can have? 2 cube, which is 8. So I will have total 8 combinations. This is 1, 2, 3, 4, 5, 6, 7, 8. Correct? So let us construct a table like this. Let's give all the possible combinations. Okay. Uh, so 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and all ones. So now how to get F? We can get it with the help of circuit. So let us first draw the circuit. Okay, how do you draw the circuit? Now you see there are three inputs, right? So you have A, B, C, and input. Now B is inverted. So B is inverted and ANDed with A. So it means I need one AND gate, correct? So A AND with B bar, I got this part. Then you have to get XOR now. So let's get an XOR gate. So A B bar, this is A B bar. This should be XORed with your C to get F. This is our circuit. So I draw the circuit. Now, after drawing this circuit, we will record the output. So I stop it and go for the new project, make it big. So I have three inputs, A, B, C, and I have one inverter with B, and I have one AND gate, and I have one XOR, correct, and one LED, which is F. Let's have a label. Sorry. So I remove it. Yeah, this is label. So let's give the name to these inputs and outputs. I call this as A, this is as B, this is as C, and this is as F. Let's give the connection. That first B is inverted as we have seen, and A dot BC, and this is XORed with C to get the output F. Okay, so now let us record the output. Now I just turn it on. All are 0. The output is 0. Okay, then 0 0 1. Output is 1 1 0. So I just make it as 1 0. Output is 0, and make 0 1 1. So output is 1 1 0 0. This is 1 0 0. Output is again 1. Then 1 0 1. Output is 0. Then 1 1 0. 1 1 0. Output is 0. And all ones, output is 1. This is what we have got, the Boolean expression. Okay. So from this Boolean expression, sorry, we got this table now. Okay. From this, this is what the circuit, and this is the table. Now you can do verification also, that whether your solution is correct or not. How do you do with the verification? For verification, there are two ways of doing verification. Okay, write the Boolean expression for f is equal to 1 for this table. Okay, so f is equal to a bar b bar c plus a bar b c plus a b bar c bar plus a b c. Now try to reduce this. Okay, simplify it to get this equation. This is one way of verification, and another way is you can just expand it. Okay, so how do you expand? Like just consider this as an x XOR f is equal to x XOR y. X XOR c is nothing but a bar b plus x c bar. Okay, now put x bar here value, you will get some equation. Solve it, you will get some equation 1, and here also you will solve it and you will get some equation 2. So both will be same, and you can prove that they are same. Your solution is correct. Okay, this is I am leaving up to you. Okay, uh, if you are interested, you can do this. Okay, so this is how you can do the verification process. So I hope all of you have understood this lab, and make sure that you submit this lab reports before time. Okay, if you have any questions, you can I'll be uploading this video in the channel. In the comments you can write your doubts, we will clarify, inshallah. Or you can meet us in the college campus and get clarification. So I hope all of you have understood. So we'll stop here and continue in the next session.